All right, so today we're combining lesson 6 and 7, looking at scaling an area. So today with scale drawings, we're just recapping and then looking more on the proportional side of things. A scale drawing is a 2D enlarged or reduced drawing of an object. Scale drawings are always proportional to the originals. A scale model is a 3D enlarged or reduced model of an object. Scale models are always proportional to the originals. So a scale drawing is flat, like a map. A scale model is 3D, like a globe. But they're both models, right? Right?
Yeah.
Okay. So that's the only difference between those two words. Scale drawing is something flat, like a map, and a scale model is something like a globe or a model car someone built or like a train set. Those are not as big as the real one, right? So it's just shrank down based on the measurements. So the scale is the ratio that compares the measurements of the drawing or model with the actual measurements. So this formula is what we just looked at for our warm-ups. The drawing length divided by the actual length. So the actual is the old one, the drawing is the new picture. So that's the same formula we just talked about for our warm-up. So when it's written like a ratio, it's the same thing. The top always written first. So the drawing length and then there's our ratio symbol to our actual. And then if we're looking at it, it's new to old. That was the other way we talked about it. All right, I want you to think about a map. Everyone has seen a map before, whether on screen or in real life, a paper version, whatnot. Okay, so pretend, in your mind, on a flat map, 1 inch is equal to 10 miles. We have to be able to write that 3 ways. What is one way I could write 1 inch is equal to 10 miles? What is one way I can represent that? Mario. Say that again.
1 to 10.
1 to 10, okay? So 1 to 10, and that's going to be inches to miles. Okay, so that's using the ratio symbol. What is another way I could write that? Quentin? Write it like a fraction? Okay, so 1 inch over 1 mile. All right, there's one other way. Ramon?
In words.
In words. So 1 inch equals 10 miles. And to your question?
No, 1 mile.
Thank you. 10 miles. Good catch. So 1 inch equals 10 miles. So with the ratio symbol, 1 inch over 10 miles, so looking like a fraction, and then words, 1 inch equals 10 miles. So you can solve scale drawing problems using proportions. We talked about that word last year in 6th grade. And most of you probably have done them, but just didn't relate it to the word proportion. Mario? You can do proportions with percents, yes. And when we get to percents, we're going to go over that way too. Yes, good job. All right, so number 9, it says the scale on a map is 1 inch equals 5 miles. On the map, Cedar Grove and Maple Township are 4.5 inches apart. What is the distance between Cedar Grove and Maple Township? Write and solve a proportion to find the distance. So, step 1, we're going to write our proportion. So, we're going to set it up. So, what is our old going to be? Because we have to take the old, which
Pardon
is...
the interruption. I need the following students to report to Ms. Dial with permission slips: Alex Figueroa, Stephen Galveo, Cadence Nagg, Ruth Matthias, Natalie McCoy, Joy Pearson, never mind, and Desiree Rayner. Desiree Rayner, Natalie McCoy, Ruth Matthias, Cadence Nagg, Stephen Galveo, and Alex Figueroa. Please report to Ms. Dial. Alex, also come to the office. Damian Lopez and Kira Kilt.
All right. So remember, we have new over old, right? So in this, what number would represent my old? The old is the original. So the original, what is the original distance? Nope, I'm looking for one number. What is the old measurement? Indira. I thought your hand was up. What's the distance of the original distance between the two cities? That's the scale, yes. What is just the distance between the two? 5 miles. So 5 miles is going to be the old, which is the original. Oh, under, what is my new measurement going to be? So it's not 5 miles anymore. What is it on the map?
10.
Read the problem. 1 inch. All right, so how many inches is it apart using that scale? What did it tell us? It says on the map, Cedar Grove and Mapletown Township are what? 4.5 inches. If inch is on the top, inch has to stay on the top. Y'all see how that matches?
Yes.
Okay, so this is going to be our x. Do we know how many miles that converts to yet? No. All right, so now we solve our proportion. So we have 1 over 5 equals 4.5 over x. So we just took the words out. All right, now this is the part where some people get stuck. They don't know what to do. So, when you are looking at proportions, you want to see what is going to have two numbers across from each other. I have a number and I have a what? What is this thing called? Algebra word.
Number.
It's an unknown number, but what's that vocab word?
Unknown value.
Starts with a V. Variable. Who said that? Good job, Soraya. Variable. So is there anything that I can solve here? No, right? There's nothing to do there? But is there two numbers I can do something here? Yes. So that means I'm going to now do 5 times 4.5. That is the math I have to solve. So I'm going to set that up. I'm going to stack it, because writing it out long ways is really difficult, especially with decimals. So that's going to be 25, 20, 22. Bring over my decimal. So the X represents how far it is on the map. So how far, so we're taking it from what it was on the map to what it is going to be in real life. So from the map, what is X going to equal? 22.5 miles in real life. So to figure out if they're talking about real life or the scaled version, look at what you're solving for. Here we're solving for miles. Can miles be on a map? Is that map going to be miles long? No. So if we're solving for miles, this would be a lot bigger number than inches, right? Yeah, it's scaled down to inches so that it fits on the map. Okay? So when you're setting this up, just it says right here, remember, drawing distance is the numerator and actual distance is the denominator. That's the same thing we just talked about for the warm-ups. Old goes under the new. So old is the original, so the map, the globe, whatever you're talking about. The top is what you're scaling it to. So inches or centimeters, whatever you're scaling it to that they give you in reference to the map or the scale on the map. Okay? Mario.
These are ways you just if you have like the inches and like say you have one inch and 4.5 inches, it's from you multiply 4.5 1 inch, so you can also do it easily. 5. Instead of doing like crossway, you use
Yes, but with this standard, they want you to be able to set up a proportion, so that's why it's set up this way for this question. Because on your EOG, you're going to see proportions. So they want you to be able to match up across from each other the same unit, so the top is both inches and the bottom is going to be both miles. So that's why they have that. So that's why you're going to have to cross multiply to figure out what your missing variable is, which in this case is X, representing the total miles. But yes, in theory, what you just said will still give you the answer. Just when you're figuring it out, these are the steps for the proportion. All right, so you guys already put that on 19. So next thing I need is, Abby, can you grab the lesson 6 summary and pass that out? I think it's the dark blue. It says 6 summary at the top. And that's going to go right on top of that so it can flip. All right, so once you guys have that, put it in your notebook, and then we're going to go over that summary so that we know what the main points of that was. Flips right on top, just like we've been doing every day. All right, so we're going to annotate a few things. Okay, so it says scaling affects lengths and areas differently. When we make a scaled copy, all original lengths are multiplied by the scale factor. So all sides multiply by the same thing. If you don't do the same thing to all sides, it is not a scaled copy. If we make a copy of a rectangle with side lengths 2 and 4 using a scale factor of 3, the side lengths of the copy will be 6 and 12 because 2 times 3 is 6 and 4 times 3 is 12. So again, looking at how do they get from the old to the new. So remember, old goes on the bottom, new goes on top. 2 goes into 6 how many times? 3, which they just said right here, scale factor of 3. That's how I figured that out. And then on the bottom, 4 under 12, 4 goes into 12 3 times. So again, did they do the same scale factor to both sides? Yes. If they only did it to the 2 and the 6, would that be a scaled copy? No. The height would change, but the width would not. It would look super weird. The area of the copy, however, changes by the factor of scale factor. So what that means is if each side length of the copy is 3 times larger or longer than the original, then the area of the copy will be 9 times. Okay, so all that really means is if your scale factor is 3, then the area is going to triple. So if the area, just look right here, the area is 8, yes, but I want you guys to look at this main part right here. It changes the factor of scale factor. So if each side length of the copy is 3 times longer than the original length, then the area of the copy will be 9 times the area. So all that means is if this is our, because our ratio is 1 to 3, right? 1 to 3 because it's scale factor of 3. Then it's going to be 1 to 3. Does that make sense? Look at our scale factor. 1 to 3 because we're multiplying by 3, right? Okay, so scale factor is 3. So think of it this way. 1, now it's 3. It's 3 times bigger. So it's going to triple the actual area. So if the scale factor is 1 to 3, so the scale factor is 1 to 3, then the area is 3 times bigger. So instead of 1, now we have 1, 2, 3. So it's 3 times bigger. And since it's only 1 square going up, well now it's 1, 2, 3 squares going up. So it's 3 times bigger. Does everybody follow that? All right, so I want us to try one thing at the very bottom. I want you to write down here. A picture has an area of 10 inches squared. If increased by scale factor of 2, what is the new area? All right, so number one, they didn't give us any side links, and they didn't give us a picture. So the first thing Ms. Steinman always does is draw a picture. So here's my original, here's the new one, okay? So the original they said was what area? You just wrote it. 10 inches squared. So I'm going to put 10 inches squared inside here. 10 inches squared. What could my side lengths have been in that picture to get 10 inches squared total? Cammie? Okay, so 2 and 5, because length times width gives me 10, right? Okay, so if the scale factor is 2, what would my new area be? Remember, again, they didn't give me measurements, but I should be able to figure that out. If I knew the original is 10 inches squared, what is my new area going to be in the new one? Carolina? How did you get 20 inches? You don't have any sides written down. The scale, so scale factor, guys, again, of area, the area you're just going to do times the scale factor. You don't actually have to have the side lengths. Does that make sense? But if we did a scale factor of 2, and our area is here, and now we've got this, do we see that we just did 10 times 2 to give us our new area, which is 2 inches squared, or 20 inches squared for our new area? All right. Next thing I need you guys to do, Abby, can you give everybody the lesson 7 summary? And I'm going to tell you guys what to do with that in just a second. All right, I want you to put the summary for lesson 7 on page 20 so that it flips up. All right, I want you to flip up summary 7, and I want you to copy what I'm about to draw. Bless you. All right, so I want us to take what we just did and now look at how the area is going to be affected by the scale factor. Okay, in the last one, we just doubled it because it said that the scale factor was 2. But I want us to look at what we're really doing with that. Because here at the bottom, it was 10 inches squared as the area. They said the scale factor is 2. So we said that we just multiply it by 2 and get 20 inches squared. But what I need you to realize is we're not just multiplying that number. We need to multiply the area. Okay? So this might make a little bit more sense when you guys see it with it broken down. So instead of just doing 30 times 4, which is not what we're going to do, we're talking about area. So we're going to do 30 times 4 squared because we're talking about area, not side lengths. What we just did a minute ago was side lengths. That's not what it asked for. So I wanted you guys to see the difference. So when it's asking you what is the new area, not what is the new side length. So if the side length was 5 and it said the scale factor is 2, we know that it would be 10, right? Okay? Area is different because area is squared. We've got to remember that area is squared. So we first have to solve this right here. What is 4 squared going to equal? That means 4 times 4, Abby? 16. So we're going to do 30 times 16. So I'm going to stack it. So we got 0.18 placeholder, 0.3. 480. So my new area is going to be what? 480 inches squared. There you go. Abby, Miss Vicky just said that your iPad's here. So does that make a little bit more sense?
Yes.
So when they want the new area, we take the scale factor, we have to square it first, okay? If they want the new side length, then we just multiply it by the scale factor. So new area, we square it first. New side length, we just multiply. Does everyone understand the difference? You will need to know that for the test. Okay, so let's look at where lesson 7 comes into play. Because like I said, these two lessons go together. And I don't want to dwell on the same thing if we're getting it. So scale factors, again, are 2D representations. Okay, floor plans, maps. Those are examples of scale drawings. On a scale drawing, every part corresponds to something in the actual object. Lengths of the drawing are enlarged and reduced by the same scale factor. A scale tells us how much the actual measurement is. We've already talked about that. Jump down to here. The width of the octagon in the drawing is about 3 times the length of this segment. So this picture right here. So the actual width of the sign is about 3 times 25 or 75 centimeters because it says it's 3 times. Because a scale drawing is 2D, some aspects of the 3D object are not represented. For example, this scale drawing does not show the thickness of the stop sign. So a scale drawing may not show every detail about it. So when I'm looking at a picture of something, I'm only looking at how many sides of it. 1. A tissue box is a 3D object, right? Okay, but if I'm looking at the front of it, I see a flat object, correct? Okay, so a picture of a 3D object doesn't tell me how thick it is or how wide it is. Okay, I'm only seeing one face of it because the 3D object has multiple faces, sides. Okay, so that's the same thing with here. In the picture here, it doesn't tell us how wide or thick the stop sign actually is. It just tells me the size of each of those sides. Okay? All right. So next thing we are going to do is work on the 2 cool downs, and I just want to make sure that we understand what we're doing for those 2 cool downs. So for lesson 6, what was the main thing I told you about? If you're finding the area using a scale factor, how do I find the new area? I have to square the what first?
Oh, the number that you're multiplying by.
There's a keyword for that. I have to square the. Somebody's saying it, but not loud enough. The scale factor. Myra, take your hood off, please. Myra, take your hood off, please. Thank you. So you have to multiply your scale factor because you're squaring it, and then you multiply it by the size of the shape or side or whatever they're asking you to do. Okay? In lesson 7, they wanted us to see that not all of the object is shown. Any questions about that? All right, so we're going to do our 2 cool downs, and then you're going to turn those in, and then we're going to also go over those 6 problems that we talked about yesterday that you put in your book that looked like this. Okay, so do your 2 cool downs, and then we're going to discuss the practice problems on page 18 from yesterday.